Hello, ladies and gentlemen. Many of you have been, I want to say complaining, but commenting, asking about your grade on this assignment, the measurement practice. And as an opportunity for you guys to do better, I want to give you an opportunity to replace that grade with a makeup assignment. As part of that makeup assignment, you need to watch this video and so that you know what you did wrong and so that you don't make these mistakes and you learn from your mistakes what happened. So what you're looking at right now is the uh, assignment that you were supposed to do. When you do your assignments, make sure you read your instructions. So it says always include the units when making measurements. And so whatever those units are, when we're measuring length, it's going to be centimeters, millimeters, meters. Volume, it's going to be milliliters, liters. Mass is going to be grams. Temperature, it's going to be Kelvin or Celsius. So make sure you tell me what it is, because if you tell me it's 10, I don't know if that's 10 millimeters or 10 kilometers or 10 elephants. I don't know what it is. So make sure you tell what that unit of measure is, what you measured. So when we started with length, as I talked the day before, we talked about we use a metric ruler. And on most rulers that you're going to see in the classroom, you're going to have centimeters. And millimeters are the small lines. So if this is 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, this here is 1 millimeter, 2 millimeters, 3 millimeters, 4 millimeters, 5. So then this is 10 millimeters. This would be 11 millimeters, 12, 13, 14, 15 millimeters. So that's how you read a ruler. Now, when we're dealing with centimeters, because there are 10 millimeters here, so this would be 1 centimeter, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. So when you're writing your measurements, don't use fractions. There were several people who put their units in fractions. Don't use fractions. For a couple of reasons, this is going to be a lot easier when you are making your graphs. It's going to be a lot easier if you're doing conversions. It's going to be a lot easier when you're doing other stuff that you may need to do later. It's going to be easier to have decimals rather than fractions. So use decimals. So if you have something in between 1 and 2, it's going to be 1 point whatever, like 1.3, 1.7, something like that. So when you were asked for the purple crayon, how long is the crayon in centimeters? So I'm not asking for an estimate. We're not going to round. We're measuring. We want exact, accurate, and precise measurements. So some people complain about not being able to see the image. So if you go up here to the 3 dots, you can make that image bigger. You can also use, I think it's Control Plus, or is it Shift Plus? I don't know. There's a key bind on your Chromebook that will also do the same thing. That will zoom in and zoom out. So, and this picture it's nice. Even got the dotted lines for you. So here's a dotted line, comes down to just right about this line. So this is 7 centimeters and 1, so 7.1. So this would be 7.1 centimeters. So then how many millimeters? Well, if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could count all those, or we could go 10, 20, 30, 40, 50, 60, 71. So 71 millimeters. Or if you know that 10 millimeters is 1 centimeter, and 1 centimeter equals 10 millimeters. So 7.1 centimeters is 71 millimeters. Now, there were some people who just put 7, as long as there was in a reasonable amount of error, I took it. And as long as if you had 7 centimeters and then 71 millimeters, I didn't give you credit for that. But if you had 7 centimeters and 70 millimeters, I did give credit for that on the first assignment. Again, here we have a screw that is 5 and then 1, so 5.1 centimeters. And then how many millimeters is this screw? So 10, 20, 30, 40, 50, and 1. So 51 millimeters. Question number 3, we have these leaves. So how many centimeters long is leaf A? So leaf A is at least 5, and this is 0.5, 0.6, 0.7, 0.8. So it is 5.8 centimeters. Leaf B is 4, approximately 4.3 centimeters. Again, we can zoom in if we need to see that it's kind of in between. So if you said 4.2, I would have taken it because it's in a reasonable amount of error, or 4.3. So then the difference, so on the difference here, as long as you had the correct number, I gave you credit for it. But the correct difference, so the difference between 4.3 and 5.8, so if we take 5.8 minus 4.3, it's 1.5 centimeters. So then how many millimeters is leaf A? So we have 50, 51, 2, 3, 4, 5, 56, 57, 58. So this is 58 millimeters. And then leaf B is going to be 40, 41, 42, 43 millimeters. So that's how you use your rulers and how you measure centimeters and millimeters. Next, we look at the volume of a solid object, and I picked a rectangular object because most of you should know that the volume of a rectangular prism is length times width times height. But I did, explain that here, and then I gave you an example of how to calculate it. So length times width times height, 6 times 2 times 4, 6 centimeters times 2 centimeters times 4. And whenever we multiply we're going to multiply the number and the units here. And so what I was trying to explain here, what I explain here is, if we take centimeters times centimeters times centimeters, it's the same as if you have 2 times 2 times 2, which we can represent as 2 cubed with 2 to the third power. So if we take centimeters times centimeters times centimeters, it's the same thing. So it's centimeters cubed. So, and that's what this is, centimeters cubed, or what we call cubic centimeters. So either way, I would consider correct. So if we multiply 6 times 2 times 4, we get 48. So we multiply the numbers, we multiply the units. So we put that all together, and we have 48 centimeters cubed. So you can write your answer like this. So then the volume of this box is 48, what we would say 48 cubic centimeters. And I know on this assignment in Canvas, it's hard to do an exponent. Some people put a caret in, and I appreciate that. That was another way that you could do that. But I just said you could write it as just CM3 without it being a superscript. So then I had you calculate the volume of this box. So we take our length times our width times our height. So 2 times 5 is 10, times 4 is 40. So 40 centimeters cubed. That's the way I actually wrote to write it. If you wrote it with a caret, it would look something, if I can find the caret on my keyboard. I don't know. I can't find it. So I did have somebody who figured out how to do superscripts. So maybe that person could teach me how to do it, because I don't know. So that's solid objects, especially regular shaped solid objects. Then to do liquids, I talked about measuring using a graduated cylinder. We look at the bottom of the meniscus here. So this would be, and we want to pay attention to our scale. So like here it says pay attention to the scale on the graduated cylinder, because they're not all the same. So on this one we have 30 and 40, and then so this would be 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So this is about 36 and a half milliliters. So we actually wouldn't mark that, like if in real life, we would just say this was 36 milliliters, because that's what's inside our range of error. And that's what our, basically based on the tool we're using, as accurate as our measurement can get. So then I gave you some volumes of liquid to look at. So what is the volume of A? So here's 20, here's 30, 21, 22, 23, 24, 25, 26, 27, 28. So this is 28 And I even gave you that they're measuring in milliliters. So then what is the volume of graduated cylinder B? 30, between 30 and 40. So that's 31, 32, 33, 34. And then graduated cylinder C would be 81, 82, 83, 84, 85. And I know for some of you who took this early, somehow I keyed that in as 55. Maybe I just double tapped the 5 instead of hitting the 8 and the 5 because they're right next to each other when I put in the answer. But somehow I fixed that. So some of you who did it later didn't notice that. So here we have 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So this is 39 milliliters. So on this one, this is where I kind of threw you a little bit of a loop. So here we have 30 to 40 and 70 to 80, just like we had up here. So this is 80 to 90, 40 to 50. On this one, this goes from 6 to 7. So if this is 6, so this would be 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9, 7. So then we're going to measure the bottom of the meniscus, which drops to about 6.2 milliliters. Now, if you put 6.3, that would be in our margin of error. I would have taken that as well. So then cylinder B, 30, 31, 32, 33, 34, 35, because this is between 30 and 40. So if you look at where this line crosses, so it technically is 34 milliliters. I took 35. Some people wrote that as well. And then this one is 70, 71, 72, 73 is where that bottom of that meniscus is. So, and then we can use liquid and use the property of displacement to determine the volume of an irregular object, something like a rock or, I don't know, something else. In our example, a ring. So we start out, we have 50 milliliters of water, and then we add this green jade sample, and we're up to 60.5. Now the amount of water didn't change, so we still have 50 milliliters of water. So we have 50 milliliters of water, and then the water plus the jade sample is 60.5. But we want just the jade sample. So if we set this up that we want jade, so jade is going to equal the water plus the jade minus the water. So the water plus the jade is 60.5. The water itself is 50, so 60.5 milliliters minus 50 milliliters is 10.5 milliliters. So the jade sample has a volume of 10.5 milliliters. And so that's how we use this property of displacement to determine volume of irregular objects. And I don't know if this may have been confusing. On the makeup, I'm going to find a different question. So it'll be a little bit different. Maybe it'll be less confusing because these are graduated cylinders, and then this is a silver rod or metal rod, a cylinder of some sort. And so I called it a cylinder. And I was also hoping that you would understand that this graduated cylinder and this graduated cylinder go together, and then this graduated cylinder and this graduated cylinder go together. So if we start with, so this is 10, 11, 12, 13, 14, 15, 16, 17, 18. Start with 19 milliliters. We add in our little cylinder, our little metal rod, and we go all the way up to 21, 22, 23, 24, 25, 26, 27, 28, 29. So the difference between 19 and 29, so if you take 29 minus 19, we get 10 milliliters. On this one, we go from here 60, 61, 62, 63, 64. We put in the ring. We're up to 65, 66, 67, 68. So if we take 68 minus 64, that is 4 milliliters. So the ring is 4 milliliters. That's the volume. So now we're going to look at some thermometers to determine temperatures. And remember, all temperatures are Celsius. And I also said you may not be able to include the degrees symbol, and so it's okay if you leave out the degrees symbol. So if you just put a capital C, just so I know that you're putting the units, since I don't know if you guys know how to put in a degree symbol. Biggest thing is here is you got to watch your scales just like we did. So here's 10, 11, 12, 13, 14, 15. Pretty straightforward. So then this is 15, 16, 17. So this is 17 degrees Celsius. And then this one's a little bit different because here we have 50, 60. So this would be 50, 52, 54, 56, 58. So here we have 60, 62, and this would be 64. So what is halfway between 62 and 64? That is 63 degrees Celsius. On here, we've got from 0 to 10. So this is 1, 2, 3, 4, 5, 6. So this is 6 degrees Celsius. And then on D, we're similar back to this one. So 35, 35.2, 35.4, 35.6, 35.8, 36. 36.2, 36.4, 36.6, 36.8. So what's halfway between 36.8 and 37? 36.9. So then on this last one, this one threw people for a loop as well. Here is 0, and here's 5. So this is 1, 2, 3, 4, 5. But we're down here below 0. So here's -5. And what I had many people do is they went from -5, -6, -7. So they put -7. But -7 is not between -5 and 0. So this is actually -5, -4, -3, -2, -1, 0. So this is -3 degrees Celsius. So I hope this clarifies any problems you had on this assignment. So if you have any questions still after I've gone over this, please email me and let me know. After watching this video, you may go in and complete the measurement makeup assignment. And what I will do is I will replace your grade from the measurement practice assignment with whatever grade you get on the measurement makeup. So if you want to do that, you may go back into Canvas, look for the measurement makeup assignment, and then you can complete that and submit it to replace your grade for the measurement assignment. Have a great rest of your day, and I'll talk to you guys soon.